Welcome to the video, Linear Equations in Two Variables, Slope-Intercept Form. So we're going to cover quite a bit in this video, so you may be interested in watching it in parts, and that's fine. But hopefully you can just kind of get what you need from the video. So if you fast forward some and get to some problems that may be more helpful for you, that's fantastic. So first of all, a linear equation in two variables. Usually the variables that we see most often are x and y. So those are the ones that we're going to be looking for. But that's not the only ones that can appear. So really the equation can have any two variables. X and y is just kind of the usual. In order for it to be a linear equation, neither variable can be raised to any power or be in the denominator of a fraction or be underneath a radical. Basically, each variable just has to have a power of 1. Standard form, this is not very helpful if you're trying to graph, unless you're using the intercepts, then it's helpful. My preference is to graph using the slope-intercept form. But this form, the standard form, is very helpful when you're dealing with systems of equations. And we will get to that soon. There will be other videos regarding systems of equations. But for now, this isn't the best form of a line as far as giving useful information in the form it's given in. Slope-intercept form is much more user-friendly. It gives you the slope. It gives you the y-intercept from the formula directly. So you'll see that the slope is m. That's always the coefficient of x. So that's the number in front of the x when it's in this form. B is the constant. That's going to give you the y-intercept. That number is going to be where it crosses the y-axis. If you know where it crosses the y-axis and you know the slope, you can draw any line. There's also another form called the point slope form, and I have another video about that form. Okay, so this video really focuses on the slope-intercept form. Number 1 and number 2 ask us to write an equation using the given information. Whenever you're given the slope and the y-intercept, you can immediately put your answer in slope-intercept form. Okay, so what you're looking for is, do you have the slope and do you have the y-intercept or the b? Number 1, they give you the m and the b. Okay, they give you the m and the b. So you can write y equals mx plus b. And you're just going to fill in the numbers. M is -2, b is 5. So y equals -2x plus 5. That's it. So if they give you the m and the b, very easy to write an equation. That's like the gold standard, I guess, the best thing they could possibly give you. Number 2, they give you the m. Okay, so that's given. Now we need a b. They do give us the b. Now, number 1, they clearly say, hey, b is 5. And number 2, they tell you it passes through this point. Remember that the b is the y-intercept. Okay, a y-intercept has an x value of 0. So 0, comma b is the ordered pair for the y-intercept. So in fact, this is the b. They just gave it to you in a different form. So we do know the b. So again, if they give you the m and the b directly, very easy to write an equation. So y equals 2/3 x, b is -1, so -1. And that's it. That's your equation of the line. So a slope, it's given by m. It's a rate of change. So it's how things change on the x-axis when compared to the y-axis. If you're given 2 points, you can find a slope using the formula m equals y2 minus y1 over x2 minus x1. Geometrically, you think of it as rise over run. Change in y over change in x. Those are all saying the same thing. The key to this formula is that the 2's are on top of each other. Notice y2 is on top of x2, and the 1's are on top of each other. y1 is on top of x1. That's very important for this formula. It doesn't matter if the y goes first. Okay, an equivalent formula is this, y1 minus y2, x1 minus x2. But notice again, the subscripts, the 1's are on top of each other, and the 2's are on top of each other. As long as your subscripts match top and bottom, you'll be okay. Okay, so this is okay. This is another version of the formula. It's fine. You do not want to do y1 minus y2 over x2 minus x1. See how the 2 is on top of the 1? This is not okay. You cannot mix up your subscripts. Okay, so again, the 2 in green are all right. All right, number 3, 4, and 5, we're trying to find the slope that passes through the given points. We're just going to use that formula, plug in the numbers, and get the slope. So if it helps you to label your ordered pairs, remember it's always x, y, and then one pair will be the 1's and another pair will be the 2's. So x1, y1, x2, y2. And I'm just going to use the formula. So I'm going to use the formula as it was given to us. So I'm going to do the 2's first, but remember it doesn't matter as long as you're consistent with where the 2's go and where the 1's go. So y2 is -1 minus y1 is 3. x2 is 1 minus x1 is -2. So the minus comes from the formula, and then the x1 is a negative as well. So we have two negatives there. -1 minus 3, those are both negative, so I add and keep the sign, so -4. And then 1 minus a -2. Remember that that really means 1 plus 2. So that would give us 3. So in this case, the slope is -4/3. All right, number 4, we're going to do the same thing. Again, if it helps to label your points, do that. Write down the formula that you're going to use, and then plug in your numbers. So y2 is -5 minus y1 is 2. x2 is 3 minus x1 is 3. So that will be -7/0. Remember, if 0 is on the bottom, that's not all right. That's undefined. So you have an undefined slope here. Okay, number 5. We have 1, -4, 0, -4, x1, y1, x2, y2. Write down the formula. Okay, and then plug in our numbers. Whoops. Okay, so we have -4 minus a -4 over 0 minus 1. -4 minus a -4. Be careful with all the signs here. -4, the two negatives together, right? These two negatives make a plus. -4 plus 4, those are opposites. That'll be 0 over -1. 0 on the top is okay, so this will be a slope of 0. Okay, so we've done what they asked us to do. We found the slopes in each of those cases. There is a video that I made regarding the special cases of vertical and horizontal lines. Those go with the slopes of 0 and undefined. So if you have not watched that video yet, you might want to just take a quick look. Whenever your x values match, like in this case, your x values match, you always have an undefined slope because your x values match. So the difference in x is 0. If there's no difference in x, the difference in x is on the bottom, you'll always have an undefined slope. Okay. On number 5, your difference in y's are 0. There's no difference, right? One y value is the same as the other. And the difference in y, or the change in y, goes on the top in this case. That means the top will always be 0. So you'll always have a 0 slope if the y values match. You will see that I have a URL here. This is what I used for our reference guide when I made this video. So this reference material is from the free OpenStax textbook. You can go here, look at the explanations, look at definitions, look at examples. They have a lot of problems for you to work out on your own, and they have the answers to the odd problems given so that you can check and make sure you're doing the work correctly. So if you have questions, or you're having a hard time with some of this, or you just want extra practice, this is a good resource for you. All right. The next thing I want to do is I want to state the slope and the y-intercept of the given equation, and then sketch a graph. So for number 6, you can see that it's in SlopeIntercept form. How do you tell if it's in SlopeIntercept form? Well, let's look at number 6 versus number 7. So number 6, the y is by itself. Number 7, this is in standard form. This has your x and your y on the left, both variables on the left, and the constant is by itself on the right. So in number 6, since it's in SlopeIntercept form, the form itself directly gives you the slope and the intercept, the y-intercept. The slope is always the coefficient of x when it's in this form. So the slope is -1/2. And when it's in this form, the constant is the b value, the y coordinate of the y-intercept. So 0, 3 is the y-intercept. So it asks us to state the slope and y-intercept. Here we go. Slope, y-intercept. Now, depending on how picky your teacher is, I am very picky. If it asks you to give the y-intercept, you can't just say b equals 3, because that's not an intercept. An intercept is an ordered pair. So you should give the ordered pair 0, 3. You can't just say it's 3 because that's only the y coordinate. That's not a y-intercept. Okay, so I like to have the ordered pair. So I did that, then sketch a graph. Very easy to sketch a graph when you know the y-intercept and the slope. You start by graphing the y-intercept. 0, 3 is the y-intercept. You graph the y-intercept first, and then you use the slope to count to find your next point. So -1/2, the negative can go either on the top or the bottom, not both. You don't apply the negative to both places because then it's positive. So -1 on top, rise over run. That is your geometric interpretation of the slope. It's how much you change in the y direction, which is the rise, up or down, over how much you change in the x direction, which is your run. So if I'm using the -1 over 2, that means I'm rising -1. That means going down, right? Going down 1 and to the right 2. And I can continue to go down 1, right 2. Alternatively, if I had chosen this fraction, the 1 over -2, that means I would be rising 1, going up 1, and -2, I'd be going to the left 2 times in the x direction. So it'd be up 1, left 2. And I could keep going up 1 and left 2. Notice that all those dots all look like they lie on the same line. That's a good sign, because this should be a line. This is a linear equation. So regardless of how you interpret your slope, either -1 over a +2 or a +1 over -2, either way, you're good. You get points on the same line. You simply connect those and you're done. Let's look at number 7. So in number 7, I want to state the slope and the y-intercept, and then I want to graph. So since this is in standard form, it would in my opinion, be easier to graph using the x and y intercepts. However, then you're still going to have to try to find the slope if you do it that way. So the easiest way at this point, since you have to state the slope and the y-intercept, is to get this in slope-intercept form. So to do that, you want to get the y by itself. So we're going to start by subtracting off the x piece. Okay, so 3x minus 3x, that zeroes out and leaves us negative 6y is equal to negative 3x minus 18. Since I'm trying to get this in slope-intercept form, that means on the right-hand side, I want the x piece before the constant. So that's why I put negative 3x minus 18. If you put negative 18 minus 3x, that's okay. That's an equivalent form, but I want the x first. That's why I put it this way. Okay, now I'm still trying to get the y by itself. The negative 6 is messing us up here. That's negative 6 times y. So to undo multiplication, I divide. So I'm going to divide both sides by negative 6. On the left-hand side, those negative 6 will divide out to 1, so I'll just have y, which is what I wanted. And on the right-hand side, I have negative 3x divided by negative 6, and I have negative 18 divided by negative 6. So each of those, you're dividing the entire side by negative 6. That means you're dividing each term, each piece, by negative 6. So if I write this out, that's negative 3 divided by negative 6 plus negative 18 divided by negative 6. So both pieces are divided by negative 6. And then I can reduce that. So negative 3 divided by negative 6, I can reduce that to positive 1/2, right? Because the two negatives will make a positive, and 3 divided by 3 is 1, and 6 divided by 3 is 2. Negative 18 divided by negative 6, the two negatives will make a plus. 18 divided by 6 is 3. Okay, I now have it in slope-intercept form. So I can answer the question, slope is 1/2, and they wanted the y-intercept. Remember to write it as an ordered pair, so 0, 3. Is this the same slope and y-intercept? Oh, so close. I did that on complete accident. So we have the same y-intercept, but the slope is different. And actually that works out pretty well. Let's look and we'll compare the two graphs in a minute. So let's do this one in blue. So first we start to graph by using the point we have, the y-intercept. So that'll be here, 0, 3. And then our slope is a positive 1/2. So that means rise over run, right? So rise 1, right 2, up 1, right 2. And I can keep doing that. Or I can go down 1, left 2. And I can keep going down 1, left 2. And then connect all the dots. And you should see that they're all on the same line because it's a line. They're collinear. So that would be the line or the graph of this equation. So really quickly, since we have these two to compare, let me shrink this down a little bit. Oops. Okay. Okay, if you look at number 6 and number 7, number 6 is in red and number 7 is graphed in blue. Look at the trend. Look at what's happening. On the red graph, if we read the graph from left to right, you can see that it's decreasing, right? It's decreasing. That corresponds to a negative slope. So whenever you have a negative slope, you're reading your graph from left to right, it should look like it's decreasing. On the other hand, number 7, again, you read your graph from left to right, it's going up, it's increasing. Notice that we have a positive slope. A positive slope is associated with an increasing line from left to right, okay? Both of these have the same y-intercept. They both intersect the y-axis at 0, 3. The difference here, and they even have a slope that's the same rate of change, right? It's 1/2, but one is negative and one is positive. One is decreasing, one is increasing. So that's actually a good kind of compare and contrast there, I think. All right. Let's move on. The last two, they give us the equation and they want us, oh no, I'm sorry. They give us the graph and they want us to find the equation. So they're giving us these graphs and we have to find the equation. So this one might seem tricky at first, but after you think about it, it's not bad. So the first thing you want to think about is what is involved in a linear equation? Well, we know we have two variables, y and x, and then we need to have an m, a slope, and a b. That's the y-coordinate of the y-intercept. So that's what we're going to be looking for when we look on the graph. We want to be able to find the y-intercept, and we want to find the slope. The y-intercept should be the easiest thing to find, so let's start there. In this first graph, the graph on the left, we see that it crosses the y-axis at 5, right? So that means b is 5. Super easy, right? That's the easiest part. Where does it cross the y-axis? The slope we're going to find by simply trying to count from one point to another. So the slope is rise over run. So I'm going to look here and find another point. It looks like it crosses right here at 4. And I'm going to count. How do I have to move to get from the red dot to the blue dot? So to get from the red to the blue, I have to go down 1, 2, 3, 4, 5 times. So the rise is going to be a -5 because I'm actually not rising, I'm falling, right? So down 5. Then, in order to get to the blue dot, I need to move to the right 1, 2, 3, 4 times. Since I'm moving to the right, that's in the positive direction. So that would be a 4. So my slope is -5/4. Once I have my slope and my b, my m and my b, I can write the equation of the line. So the equation of the line is y equals -5/4 x plus 5. Okay, so you're just finding where it crosses the y-axis, and then you're finding 2 points to count to find your slope. All right, let's look at the one on the right. So again, we're going to start by finding the y-intercept. This one looks like it crosses at -1. That means b is -1. I'm going to find another point. It looks like it crosses here, right, at 1, 2. So I'm going to figure out how do I move from the red dot to the blue dot. So in order to get from the red to the blue, I need to go up 1, 2, 3 times. So that would be up 3, so it's a +3. And then I need to move to the right 1 time. Right is positive. So that would be 3/1. This reduces to 3. So our slope is 3. So I can write the equation of the line. Y equals 3x minus 1, since the b is -1. And that's it. A quick check you can do is just to kind of look at the trend of the line. If I look at the line on the left, it's going down from left to right. It's decreasing. That means my slope should be negative. It is. So that's a good check, right? The line on the right, if I look from left to right, it's going up, it's increasing. My slope should be positive. It is. So that's another good sign.